Okay, first thing you have to understand about the capacitor. You see that capacitor here, okay? And now, the capacitor will be deal with either a DC circuitry or AC. What they telling you
Professor, I
here?
can't see anything on your screen.
Can you say again?
I don't see anything on your screen.
You didn't see
Are you
any.
showing something? Are you showing something on your screen right now? I don't see it.
I
Okay, I
see
see it.
it.
I'm sorry. I'm sorry. I'm sorry.
It's okay.
Yes, you're fine. We can see it.
Okay. And now, what they telling you, capacitor reactant. Okay. Xc equal 1 over 2 pi times F times C. Okay. Where Xc will be in ohm. Pi you already know, 3.14 joule. F will be in hertz. C will be in farad. That's only telling you one thing. When the capacitor connect into the AC, they will be get the resistance. Okay? That resistance will be Xc equal 1 over 2 pi times F times C. Okay? And Xc will be resistance, so unit will be in ohm. Okay? And they can telling you, okay? The capacitor for the AC here, they will be shorted. Okay? And if it's at the DC, they will be open. Okay? For AC analysis, capacitor is shorted. DC analysis, capacitor will be open. The reason they open the thing is when the capacitor gets a full charge, so no current can be flowing through it. Okay? However, on the AC, they will be get a resistance, and that will be they call a capacity reactance, XC, and they already given you the formula how to calculate it. Now, amplifier analysis. First thing, you have to perform complete for DC analysis. That means you have to working on the DC before you can get into the AC. Second thing, short on coupling and bypass capacitor. That means you didn't see any more capacitor on the AC. The thing is, they will be shorted. The next visual line on DC supply voltage at AC round. Okay, that will be telling you in the AC you didn't see any more DC voltage. The thing is they will be shorted, okay, to the round. Replace the transistor by or the module. That means for AC you can get a different, okay, transistor. And last thing, raw AC equivalent circuitry. That is the process to working on the AC. Okay? The thing is we are technician. So that is basically technician need to know. But normally you can see everything now. You don't have to do. The thing is you can using the simulation, MSIM simulation, or PSPI simulation. You can get anything you wanted. You don't have to do your calculation. However, if you keep moving up to engineering level, then they go detail on this thing. Okay, now you can see the transistor DC, they draw this way. That's a DC, you already know. And now, for the AC, this is the AC module. Input the base, okay? And this is the collector. Okay, collector right here. Okay? And this is the ammeter right here. Okay, you see what the difference between DC and AC. This is the base here. Okay, ammeter here. And a collector here. Who's telling me the difference? That's what they're using the T module. I can tell you.
The base is coming in after the transistor.
If you're looking into it, you can see on the DC, this is the base, and this is the ammeter. The difference between the base and ammeter will be the diode. However, on the AC, that is no longer diode there. That means between the base here and the ammeter here, Okay, you get the resistance R prime E. And that resistance will be calculated here. R prime E equal 25 millivolt divide IE. That is telling you the difference between DC and AC. For DC, from base to the ammeter, you get a diode 0.7 volt. However, for AC, from the base to the ammeter, you get resistance R prime E. And that resistance calculated by 25 millivolt divided to IE. Okay? In here also, they given to you input impedance G in base VBE divide IB. Okay? And VBE equal IE times R prime E. Okay? That means from the base to the ammeter, okay, the current how come they not working? Man, I don't know. Just the pain, just the problem or what? Man. Let's see, how can we show you? Just a minute. Ah, okay, I find out. Okay, let's see. G in B equal beta times R prime E. Okay? Now, if you get an amplifier, you get an input here. Okay? And this is the output and the gain, 200. So the gain, basically, by definition, equal V out divide QV in. Okay. The fourth one we're talking about common emitter amplifier. Basically, you get three. First one, common emitter amplifier. The second one, common collector amplifier. And the last one will be common base amplifier. Okay? So now we're talking about the first one, common emitter. When you're looking into the amplifier, basically you have to recognize what common, emitter, collector, or the base. Based on what happened here. First thing, this is the input signal. Okay? So, input signal to the base. Okay? That means this is the base. Input signal applied to the base. Output from collector. This is the output here from the collector. Okay? And also input and output 180 degrees out of phase. That means they opposite. That is basically you have to know. When you're looking into the amplifier, you have to know, is it collector, emitter, or the base amplifier? Based on what I just talking to you. Common emitter, input applied to the base. Output from the collector. And input-output opposite, or 180 degrees out phase. Now, next thing, you can see inside circuitry you get C1 capacitor C1, C2, and C3. Three capacitor. Okay? And now, what is C1? C1, DC blocking, AC coupling. What that mean? That means any DC from the input cannot go into the transistor. That is DC blocking. However, if you get a sideways AC input, then you get a sideways. Get through it. Okay? That's what they call AC coupling. Okay? So input sideways, and at the base here, also you get a sideways. C2, same thing. DC blocking and AC coupling. Normally the load in here, in the amplifier, there will be a speaker. Okay? So at the collector here, okay, this collector right here, okay, you get two signal. First one will be a DC voltage, okay, and also you can get a sideways coming here, AC. So when you connect to the speaker here, you need the capacitor here. This capacitor will be block the DC, okay, from collector. So that DC cannot go to speaker. They allow only the void AC signal go to speaker. Okay? And the last capacitor here, C3. Okay? C3 will be a bypass capacitor. Now, what that means? That means when you get at the Admitter here, okay, you get a DC and you get a AC. Okay, so capacitor will be shorted for the AC. So when the signal coming in here, you cannot get any sine wave here. No sine wave. The thing is, capacitor will be shorted, so they will be shorted throughout. Okay, so AC, they not go through RE. The reason is the capacitor already short to the route. That's why they call a bypass. Okay, bypass what? Bypass RE. That means AC not go through RE. They go to capacitor C3, connect to the route. So that is the first thing you need to recognize for common admitter, CE amplifier. Okay, so when you're looking into the circuitry, first thing you need to recognize what amplifier, CE, CC, or CB. Okay, and also for the CE amplifier, you get C1, C2, C3, and you have to understand the purpose of this capacitor. C1, DC blocking, AC coupling. That's only telling you at the input coming, there's the input here. Okay? Only AC will be go through the base of the transistor, not DC. The C1 will be blocked DC. And only AC can go. That's what they call it, AC coupling. And the next capacitor C2, same thing. At the collector, you get DC voltage and AC signal. C2 will be block the DC. Allow only AC go to the load. That C2 will be same thing, DC blocking, AC coupling. And the last one, C3, okay, that will be bypass capacitor. That means at the admitter, you're supposed to get AC sine wave. However, capacitor will be shorted for AC, so that's why they will be shorted throughout. They bypass RE. That means no current IE go through the RE. Okay? So that's a general picture for common admitter. You can get any question about this amplifier. The thing is, if you understand when you do the left volt, that's a very exciting. Okay? Now we'll see. Okay, now This will be CE amplifier. Okay. First thing we have to do for DC first, right? We already telling you at the beginning. Have to complete DC calculation. So first thing you calculate it. Okay. At this point, the base collector at meter. Now, first thing, at the base, you get the DC 1.8 volt. How come you get 1.8 volt? VB DC equal 10 times R 2.2 divide 10K plus 2.2K. That you get 1.8 volt. That's a voltage divider. Okay? When I get through it, if you get a question, just go up and bring it up. Okay? Okay. At the base, you get 1.8 volt. Okay? At the meter, what DC you get? That means VE. VE equal VB minus 0.7 volt for diode. That given you 1.1 volt. Okay, so that's why you can see 1.1 volt. Okay, so now how do I calculate the VC? Okay, VCC minus IC times RC. Okay, so you can see this is the current flowing here. IC, IE. Okay, easy to calculate the IE. VE divide RE. VE 1.1. divide 1K. 1.1 milliamp. Okay. If you get IE, you can calculate the IB. IE divide beta plus 1. Okay. Okay, so in here, they don't care. Go to the detailed calculation. So that's why they not given to the beta. Okay. After you get IB, you can calculate the IC. Beta times IB. Okay. That is our own DC calculation.
How are we finding the beta?
Yeah. That means in here, we don't care about calculation, the formula here. So that's why they not show you the beta. If they give beta, you can calculate it. Now, first thing, you get 100 microvolt here. So basically, 100 microvolt coming in here. When they go to the bed, you can see right here, 100 microvolt. So if you're looking at signal at the bed, how can you set up your oscilloscope in order you can see the signal AC? The thing at the bed, you get two signals. One will be 1.8 volt. Okay? Right here. 1.8 volt DC. And also 100 microvolt AC. When you're working on the lab, how can you see your sideways signal? Who knows? How can you set up your oscilloscope so you can see 100 microvolt AC? Otherwise, no way you can see 100 microvolt. The thing is you get a DC 1.8 volt, too big. Who knows? Telling me. Hello, Mr. Smith.
Yes. Go ahead, Mr. Pham. What did you say?
What I'm saying is, you're using the oscilloscope to measure signal at the base. You want to measure 100 microvolt sideways. You know at the base you get two signals, 1.8 volt DC and also 100 microvolt AC. My question is, How can you see 100 microvolt AC? The thing is that too small compare.
AC coupling.
And you
Oh,
gotta, you
but yeah,
gotta do coupling.
you got very good man.
We're gonna give him a certificate.
Yeah, he understand. That means when you want to measure the 100 microvolt AC on your scope, you have to set AC coupling. So they ignore 1.8 volt DC. So that's why you can see the sine wave. The thing is you are a technician. The lecture you can understand or not completely, that be fine. However, you do it. You have to know how to do. That's your job. Okay? So when you measure at the base, your scope must be set to AC coupling. So they ignore 1.8 volt DC. So that's why you can see the sine wave. Okay, if you get any question, just bring it up. Okay. My next question. You understand on the left wall, you get the generator. Normally, generator output you can get from minimum. It goes to 1 to 2 volt. Okay. If you want less than 1 volt, 500 millivolt output, then you have to do what?
You have to couple or AC DC coupling, or is that the
No.
answer?
No. My question is output of your generator. Normally they given you
I forget the name, but it's you have to pull that knob out and then turn it.
exactly. Pull that out, right? When you pull the offset out, the voltage output of generator coming out minimum or maximum only from 300 millivolt up. You cannot get 100 microvolt. Then what can we do? Mr. Smith, you know it?
What do you need, Mr. Pham?
What?
If you don't have enough, if the voltage is too small,
Yeah, the thing is 1 microvolt. Right?
then you gotta,
Your generator can be even out. If you pull the offset out, you get 300 millivolt peak to peak. Cannot be lower than 300 millivolt. And now they're asking for 100 microvolt. Who knows? How can we get 100 microvolt?
when your generator, I forget the name of that knob, is that the, trying to think of the knob on the generator. You gotta pull it out.
Pull offset out, you get a 300 millivolt. Not up to micro.
Think of the name of it.
So if I'm understanding this correctly, to get to millivolts, we have to pull something out of the oscilloscope.
No
No,
more.
no, the generator.
Then
So we have to tweak something in the generator in order to get
you cannot get any voltage out of generator less than 300 millivolt. And now they say, I want 100 microvolt.
Oh, Mr. Fan, are you talking about the attenuation?
Exactly. That's what I'm talking about that. Okay, now, that will be help you guys. If you, when you're working, when they need that small voltage on your left volt board, they get that one they call a attenuator, right?
Right. And that will allow you to drop down smaller.
Right.
So you have to do both. You have to pull the offset knob to get to 300 and then do the attenuation, or can you just go straight to attenuation?
You can go to the attenuator. In, out, on your left volt. They given to you ready. So you connect the generator, go into in, generator, and you connect out, go to your sideways circuit, your board. Then you can adjust, okay, attenuator to voltage you want. The thing is when they build the left one, they already prepare that, okay?
You're talking about the lab on the lab vault that deals with the attenuator and how to adjust it on the input.
Right. You connect generator output to the input of the attenuator, and the output attenuator connect to your circuit. And you can adjust the attenuator, just a voltage divider inside.
Okay, so this
Can be
is
any voltage you
on
want.
the lab volts puller. This is not on the oscilloscope or the generator, correct?
Right. They already prepare for your guy. When you need microvolt, 100 millivolt, 50 millivolt, they know oscilloscope cannot do it. No, generator cannot do it. So that's why they're adding the attenuator. So they try to divide signal, okay? So you can get into the voltage you want.
And there's no maximum load that the attenuator can take in. It'll automatically set that for you,
Yeah.
or
Just connect the output of the attenuator to scope, and you can adjust to any voltage you want.
okay. Thank you.
Mm-hmm. So that's why I said, if you understand it, then that for no big deal. You can get it done quickly. Okay? Now, so at the base, when you measure, you can get a sideway here. Okay? AC coupling. And when you measure the AC at meter, you get nothing. Right. The thing is capacitor C3 shorted to round. When you measure at the capacity collector here, okay, have to be in AC coupling. So that's why you can see only this sideway, okay? And you measure the output here, okay? Then you can see the same signal. That is a completely everything regarding to common admitter. The thing is you understand one common admitter is if to following for CC amplifier or CB amplifier. Okay, let's see. This model best illustrates that A. That means they given to you the formula again. Now, see what happened here. First thing, you get a sine wave here. Okay, input applied to the base. Okay, and output from collector. They're telling you common admitter. Okay, now we'll see. If you're looking into this circuitry here, when you go to the AC, they already telling you at the beginning. On the AC, any DC will be connected to ground. You don't see any 10 volt anymore. Okay? So if you connect 10 volt to the ground, R1 here, one side go to the base, the other side go to the ground. That's why you can see here, R1. Okay? One side go to the base, the other go to the ground. R2 here. One side go to the base, the other side go to the ground. That's R2. Okay, and now the next one will be RE. You see that RE right here? RE means for AC, they from the base to admitter. That's why you can see R prime E right here. One from the base, the other admitter around here. Okay, that means for the input and the output here. You see you get RC right here. RC connect to collector and the other one side connect to 10 volt and now 10 volt AC ground. So that's why you can see RC connect one side to collector, the other side connect to the ground. And the last one RL. RL here. One side connect collector, the other side connect to the route. So that's why. That completely for the module.
When you short out the capacitor for the load.
Yeah, we don't have a capacitor in here.
No. I'm saying before you got to that point.
Before I get to IL,
Go back to the other screen. Yeah, right there. Capacitor C2's got to be shorted out.
right, AC, they sorted out.
And then it'll be in parallel with RC.
Exactly.
And then that's where you get the AC component.
That's why I get connect here. You see no capacitor in here. This
Right.
is this is for AC. Capacitor will be sorted. You doesn't see. You see C1, no C1. Okay, no C2, and also no C3. This is a AC. So capacitor already sorted to the route. So now look into here. First thing, if you want the output impedance, that means you're looking here into the amplifier. We call it Z out. Okay, Z out means output impedance. Okay, they will be equal RC parallel RL. Okay, however, if you're looking in here, they call RC. RC RG out, same thing. Okay, R mean resistance. C a lowercase letter, AC resistance equal RC parallel RL. But normally we're using G, output impedance. The textbook uses R small c, same thing. That's the first thing. We calculate the input impedance. And now we need to know the input impedance. That means you're looking from the input signal, okay, to the circuit. That's what they call a G in. Now, what G in equal?
Vn is equal to R1 in parallel with R2 and parallel with R prime E.
Perfect. You can say R1 parallel R2 and parallel R prime E. Okay? And the gain of amplifier. Okay? See, gain is here. V out divide V in. Okay? And the gain, they already given to you here. RC, that means G out divide R prime E. That's one of the formula you need for the common meter amplifier. If you're doing a calculation, then you have to understand the formula they're using in here. So to get the right answer. Okay, any question on that? Okay, we can go next. Let's see. This is an example. Okay, example here. Okay, this is a DE amplifier. You get input 10 volt, 10 millivolt IMF. Okay, and everything here. They can give you beta. If you calculate DC, you're using this beta. AC, you're using this beta. Okay? Now, this is let's see. They want calculate the VB. Okay? Voltage divider. This I already given you. The formula here. If you calculate the VB, VE, if you want IE and IB, IC and VCC, that DC calculation. Okay? You have to try to do it. That's a very basic for technician, minimum requirement. Okay, now they're talking about AC value. That means first thing you need to calculate R prime E. Okay, we already know the formula. 25 millivolt divided IE. And you need to calculate the R in B. Okay, that means R in B equal what? Beta times R prime E. And finally, you need the input total will be R1 parallel R2 parallel R in base. Okay? And they want to calculate the Z out. Okay? Output impedance. We already do it for you. Okay? If you're looking on that one, okay, output impedance. Let's see. RC 1K. Okay. Parallel to a load. This one look like we don't have a load here. A load here. 5K. Okay. So 1K parallel with 5K. If you want the gain, RC over R prime E. Okay. And V out equal the gain times V in. Okay. We go quickly through CC amplifier. Common collector. Also known as meter follower. Common collector or meter follower. Same name. Collector is AC round. Stable voltage gain. High input impedance. Low distortion. That is something you need to know about common collector. Okay? Either they say CC amplifier or they say admitter follower, same thing. So collector will be at the AC route. Very stable for the gain. High input impedance and low distortion. Okay? That one will be make. Okay? Simple than the other one. This is the base. Okay? And the output will be from meter. You see that? This is the V out right here. That's from meter. So that's why they call a meter follower. Okay? Meter or V out will be the same. Okay? VE. V out. Okay? I'm using a lowercase letter for AC. Okay. Now, this one, very simple. If you want to calculate the VB, voltage divider. Okay. And VC or VCC the same. Okay. And after I'm talking about DC calculation, you can calculate the VE equal VB minus 0.7. Okay. And after you get the VE, you can get the current IE. Okay. Now, input applied to the base, output from ammeter. Okay. C1, same thing. DC blocking, AC coupling. C2, same thing. DC blocking, AC coupling. Okay. Input and output will be in phase. Okay. Input go up, output go up, input go down, output go down. Okay. It's not like common ammeter. So that's a very, very simple common ammeter. Now, they draw AC module. This is the base. This is the ammeter here. Okay. From the collector to the base, you get a current source. That will be, okay, alpha AC times IE. That's the current. And from the base to the ammeter, you get R prime E. Okay? From the ammeter to the ground, you get RE. Okay? Ammeter to the ground, you get 14 RE. Second thing, capacitor short, so the IL parallel with RE. That's why they draw here. R out equal RE parallel with RL. Okay? This the thing is, I take from the textbook, so they using E lowercase, that's for AC. And normally, we can using S G out. Okay, same thing. So they already given you here. R in base. That means you're looking from the base. Okay? So you can get beta time with RE. That are in base. R in total will be R1 parallel R2 parallel R in base. Okay, let's see. R in base. That means from the base to the round. Okay? You can get R prime E plus R E. Okay? Times beta. Okay? And the total R in base, R1 parallel R2. You already know that. If you converting that one into AC, R1 parallel R2. Okay? So next meeting, I will give you a little detail on how to draw that one. Okay. And that will be example. For the CC amplifier. They want to calculate whatever here. Okay. So if you get the time, okay, you try your best to see can you get that. Okay. Let's see. Did another one for common collector. Okay. If you get a time, you try to do calculation. Okay. Same thing here. So we will be left over only one common base amplifier. And summarize here. So I want to say that for next meeting, okay, the next meeting will be same thing on Thursday for now. Okay. The thing is, I saw some students doing the left vote. However, they're not into the Zoom. How can they understand? That's what I try to figure out. Okay. The thing is, you not get a lecture. You don't understand. Okay. How can you do it? The thing that we get, you understand, we get a big problem with the website. That website, I already pay almost at least 10 years. What happened now? They down and they don't want to fix. They want to get a new. That means they try to get a different pay month. Even I pay by myself, not school. Okay? That's why I have to find a different way we can do without the website, with the different company. They're not doing good. The thing is, we started 10 years ago, so it pay not much, like $100 a year. And now they want more. That's why we don't want that. Okay? And the other thing, I can using the canvas in the CD, FDC CD. However, for Tech 1, that will be okay. However, for Tech 2, that's a different. The thing I cannot get into Tech 2. And I the one running either one, Tech 1 and Tech 2. So that gives, this is a program. It's not a single instructor run one program, no. In this program, I run everything. The other instructor, they just a lab instructor or helping instructor. they cannot do anything. And also, last week I've been in the class Monday, Tuesday, Wednesday, and we get a problem also with the computer. That's for Tech 2, not for Tech 1. Tech 1 you're working on level.
Hey, Mr. Pham, real quick.
Yeah,
So what you just said was, I think Ty might have said it yesterday. So the instructor 2 on the computer in the lab is not working correct. So that's why we can't run the D labs. Is that correct?
exactly. That's what I hope Monday we can fix that. I have
Because
right
Tech
now.
2 cannot do any D labs if instructor 2 on the computer in the lab 250 is not working.
I know what's going on, what's wrong. Okay. Right now, I have to fix on up the computer on the lab for Tech 2. Okay. I have to install, make sure we can get on up the computer, you can run the lab no problem. Okay, that's what I have to working on. Second thing, I have to working on. You can download or upload from the cloud into our server, and I can look into that. Okay, try to verify you done or you not done. For example, for this Zoom, I try to see, can I upload it into the server computer in the cloud, okay? And you can copy and run. But Monday, you're telling me more things. Reason is I'm not as younger like before. So that's why take a little time to get through it. But we will do it. Also, this time we can get 43,000 budget to buy for left phone, oscilloscope, generator, whatever need. Okay, so I hope we can get much better. Okay, you want to be a technician, complete this program. You have to do on job of things you have to do. And the left phone have to get it as much as you can, okay, to get through it. If you get it done everything on the left phone, then you can take it easy, no big deal. Okay? Any question before we stop it?
Nope.
Okay, so basically we will be stop the meeting today. Okay? The thing is right now, I saw around, let's see, 7 students in Tech 1 on the Zoom. I don't know the other student. I will be at them. Okay?
Maybe they need some help on how to do the Zoom, Mr. Pham.
Maybe. I will be at them if they still want to be in this program. Okay? Otherwise, they can make a different choice. Okay? So,
Okay, thanks a lot, Mr. Pham.
yeah,
So
I
just one
Thank
last
you.
question.
yeah,
So we should just come into class from Monday to Wednesday and wait for the emails for Zoom
no,
until the website gets fixed?
no, don't get the email. But you make sure you know every Thursday you get a Zoom.
What
Right?
about Friday?
Friday take Zoom.
Only
Not-
Tech 2.
Yeah. Friday take Zoom.
Okay.
Or,
All right, cool. Okay.
yeah, special for take Zoom. Or,
And the videos and the extra resources that you used to have on the website, is there anywhere else I can go get that?
okay, that's what I'm working on. Okay?
Got it. Okay. No
We'll
worries.
let you guys know how you
Got it.
can watch the video. Okay?
Okay.
You're still going to post
you.
the videos on your YouTube channel, correct?
Yeah.
Okay.
Do
Okay.
you have two different YouTube channels? Because I think Professor Ty has one as well. Or is it the same one?
Mr. Tai don't have any more Zoom.
Okay.
The thing is,
Okay.
I stopped Zoom on Friday left vote. Okay? Now you can get only one Zoom for lecture. And left vote, if they need, will be doing in the class. Try to help someone cannot understand. If you understand it, you keep going your job. So that's why I want to do it in the class. Otherwise, the way he run in the Zoom for left vote, okay, it's not really help. That's why I stopped that. You understand every instructor in this program, they can on what I want them to go to do. They have no choice. Okay? So, good night to everyone. Have a good weekend.
Thank you.
Okay? Bye-bye.
Thank you, Mr. Pham. Bye.
Thank you. Bye.
Bye.
Bye.